GATE 2019 Civil Engineering Set 1 Question 29. For the following statements, the statement P says the lateral stress in the soil while being tested in an odometer is always at rest. The statement P says for a perfectly rigid strip footing at deeper depths in a sand deposit, the vertical normal contact stress at the footing edges is greater than that at its center. Statement R says the correction for overburden pressure and dilatancy are not applied to measured SPT N values in case of clay deposit. The correct combination of the statements is option A is true, true, true. Option B is false, false, true. Option C is true, true, false. Option D is false, false, false. Reference to the relevant NPTEL courses and video has been cited. Now coming to the useful data, the statement P says the lateral stress in the soil while being tested in an odometer is always at rest. As we all know that the characteristics of soil during 1 degree consolidation or swelling can be determined by the help of odometer test. So we know that the odometer test is basically used for the Terzaghi's 1 degree consolidation, where we study the stress and strain behavior of a particular soil body. So in an odometer test, stress is applied to the soil specimen along the vertical axis and the strain in the horizontal direction is prevented. Therefore, the lateral stress in the soil while being tested in an odometer is always at rest. So statement P is correct. This is saying that if this is a soil body, we are applying the stress in the vertical axis and the strain in the horizontal direction will be prevented. So we can say that the lateral stress in the soil while being tested in odometer will always be at rest. So statement P is correct. Now coming to the second statement, which says that for a perfectly rigid strip footing at deeper depths in a sand deposit, the vertical normal contact stress at the footing edge is greater than its center. So as we can see here that here we have rigid footing and here we have a flexible footing, and we can see the study of their settlement and contact pressure at different soil. So for rigid footing, the settlement will always be uniform. As we can see here that for any kind of soil, the rigid footing will have a uniform settlement, but in case of clay, the contact pressure is higher at the edges and it is somewhat lower at the middle portion. And in the sand we can see that the settlement is uniform, but the contact pressure is very low at edges and it is very high at center. Now coming to the flexible footing, here the contact pressure will be uniform, but the settlement will be varying. In the clay we can see that the settlement is quite low at the edges and it is very large at medium, and the contact pressure is uniform. And coming to the sand in flexible footing, the settlement will be larger at edges and it will be low at center. But in question we have been asked that what we will see in the deep rigid footing on the sand. So as you can see here, in the case of rigid footing for sand, the contact pressure is low at edges and we can say that it is somewhat high at the middle portion. But for deep rigid footing, it behaves like a rigid footing on clay soil, where the contact pressure will be greater at edges and it will be shorter at, or we can say it will be minimal at the middle portion. Now coming to the third statement, which says that the corrections for overburden pressure and dilatancy are not applied to measure SPT and values of in case of clay deposit. Firstly, we have to understand that what is standard penetration test. This standard penetration test is a kind of an in situ test which is useful to measure the angle of shear resistance, which we denote by phi, and the relative density of the cohesionless soil. In the SPT test, first we create a borehole by using the drilling tools of 100 mm to 150 mm, and for the soft clay or loose clay we have to provide casing so that the borehole is not collapsed. And after getting the desired depth of borehole, the drilling tools are removed, and after removing the drilling tools, we put the standard split spoon sampler into the borehole and lowered it to the bottom of the borehole. Now the standard split spoon sampler is first allowed to sink by its own weight, then a number of blows is applied. Now we drop the hammer of 63.5 kg weight from a height of 75 cm at the rate of 30 blows per minute according to the IS code 2131 1963. Now the number of hammer or the blows penetration up to 150 mm depth is recorded, and the further number of blows is recorded for 2 more 150 mm depth penetration. The number of blows required in the first 150 mm penetration are ignored, and the number of blows recorded for the last two 150 mm for 300 mm penetration are used to find the standard penetration number. In standard penetration test, we have two corrections. The first correction is overburden pressure correction, and the second one is dilatancy correction or water table correction, or it is also termed as fine correction. The water table correction is always applied after the overburden correction. See what happens in the overburden correction, that it is mainly required in the cohesionless soil or granular soil, and the dilatancy correction or water table correction is applied in fine sand and silt when the water table is present. We have some numerical formula for calculating overburden correction and dilatancy correction. The overburden correction is, as we have studied, that it's used only for cohesionless and granular soil. So after getting the observed value, we can calculate the overburden correction, which we can write as by 70 plus sigma bar, where sigma bar is the overburden pressure and N0 is observed value of the number of blows, and N1 is the corrected value after the overburden correction. And if N1 is less than 15, we don't use the dilatancy correction, which is used for fine sand and silt only. And if the overburden corrected value is coming more than 15, then we use the dilatancy correction, which we can write like N2 equals to 15 plus half N1 minus 15. Now if you simplify it, N2 will be half N1 plus 15. So this is the two formula which we use for overburden and dilatancy correction. Now coming to the solution part, all the statements which we have studied till far, all are correct. Option A is correct. Reference to the relevant NPTEL courses or video has been cited.